Hi, everybody. We're going to do factoring. This is going to be the special cases for quadratics. So here we go. I haven't previewed it. I assume it's going to be the perfect squares and the difference of squares, but we'll see. Yep, difference of squares. That's what we call this thing because 4k squared, sorry, 4k squared is a perfect square. And 9 is a perfect square. And we call this, because this is a subtraction, we call this a difference of squares. And the thing about it is that our middle term is 0. So it has to be canceled out. And the way to do that is to get equal and opposite parts. So we want our 2k and 2k and 3 and 3. And we want to get a 0 in the middle. So of course we want a positive and a negative, which gives us positive 6k minus 6k for our middle terms, and they cancel out. And of course our 2k times 2k is 4k squared, and our 3 times negative 3 is negative 9. So there they are. Needs parentheses, doesn't it? So we have a 2k plus 3. Oh, come on, get out there. Out. There we go. And a 2k, need a space maybe, minus 3. So some people call this the a squared minus b squared special case, or a difference of squares. But there it is. You always have a plus and a minus. You always have the same things, yada, yada, yada. Now this one, I suspect, will be our perfect square, and it is. This is what's called a perfect square trinomial, and it's of the form something squared plus double the product plus something squared. It's always like that, and we want to recognize it when we see it. I'm going to go ahead and write it. 16j squared plus 8j plus 1. If you see this situation, 4j and a plus 1 and a plus 1, it happens to be what we call a perfect square trinomial. And notice that the 4j and the 4j are equal, and that the middle is double that product, because there's 2 of them. And that's our 8j in the middle. So there's 2 ways to write this. We can write it as 4j plus 1 times 4j plus 1, but we could also write it as 4j plus 1 squared. Let's see if it lets us. I think it will. 4j plus 1, and we'll go out and we'll square it like that. We could also write it 4j plus 1 times 4j plus 1. Let's see if it likes this. It might. Yep, it did. This is a difference of squares, so it's going to be the 2c plus 1 and the 2c minus 1. I'm putting spaces around my minus so that it sees it. Now this one, you can't write it as a square, because notice that they do have different signs. There's a positive and a negative part. But you'll notice that some of the things are the same. We're taking the square roots of the firsts and the square roots of the seconds. This is a very, very obvious perfect square trinomial. And the reason it's important is that eventually you're going to want to be able to do a thing called completing the square, which is they'll give you this, or you're going to have it in some way, and you need to understand what goes here to make this a perfect square trinomial. So you need to be able to recognize the pattern. One of the things is always a positive at the end, because it's going to be a perfect square. And of course, we're talking about z plus 4 squared. And there we go. And in this one, we're talking about 2d minus 1 squared. Notice that even though this is a positive at the end, of course, the middle makes it a perfect square trinomial. I think that's pretty clear. Hopefully you can see where it's coming from. We've got a 2d minus 1. Oh, sorry. I want to put the spaces because sometimes it doesn't recognize it. Come on, out there. There we go. Squared. Some people ask me the product of what squared? Well, if you take the 2d and you take the minus 1 and you take the product of those two terms, you get negative 2d. Well, when you double that product, you get your middle term. That's the pattern I'm talking about. And that middle term is negative 4d. So anyway, there it is. That's the product I was talking about that gets doubled. In case you're wondering about the background, I lost my aardvark. I decided to go with the Christmas because this is a Christmas present. It's just too easy compared to the last one anyway. So this one is going to be a 2u plus 7. And how about 2u minus 7? And there they are, difference of squares. We like difference of squares. And this one could be a perfect square trinomial, and it just happens to be. And notice that I want to point it out again. 7s is the square root of 49s squared. And the square root of 25 is 5 or negative 5. And it happens that we need a negative in the middle. So I'm going to go with negative 5. Now the question is this a perfect square trinomial? And of course, it's in the special case section, so I'm suspecting it is. But what you want to do to check it is you want to multiply these two factors together. These two terms together. Negative 35s is the product. And if you double it, do you get the middle term? And you sure do. So 7s minus 5 squared. There we go. Perfect square trinomial, difference of squares. 7n plus 1. And come on, how about a 7n minus 1? And there we go. And it is a difference of squares. Is it a perfect square trinomial? Probably. 5h. It's always good to check. 8. Multiply them and double it. That's 40h. Is it 40? Doubled is, sure enough, our 80h. Remember that the middle term is always double the product. So yeah, it's 5h plus 8 squared. Difference of squares. 5x plus 8 and 5x minus 8. Yep. I'd like to double check, make sure I actually wrote what I thought I did. Okay, is that one a perfect square trinomial? And sure enough, it is. Notice the product of 5m doubled is 10m. So m plus 5 squared. Oh, not there. Outside, there we go. And a difference of squares, f minus 7. And an f plus 7. Yep. Oh, could it be? Well, let's see. This is a perfect square. That's 12p squared. This is a perfect square. That's 11 times 11. Notice that we have a minus in the middle. They want to scare us. It's not that scary. And the question is, does this work? Well, 12 times 11 is 132. And if we multiply those, we get negative 132p. And we want to know, is the middle term double that? And negative 264p is double the product. So yeah. So we've got 12p minus 11, and it's being squared. Oh, now that's more interesting. Notice that that is not a perfect square. That is not a difference of squares. However, we could take out a factor. I get a lot of students that tell me in their head, supposedly, that they are going to write the factors. They're not. They cheat somehow and factor it using Math Popper or something. Well, notice that 3 goes into 12 and 3 also goes into 75. We need to take out the common factor. And the common factor is 3. That gives us 4w squared. And I'm undistributing. So what number do I have to multiply it by 3 to get 75? Well, that's going to be my minus 25. And now I have a difference of squares. So this is going to be 3 times 2w minus 5 plus 5. And there are my factors. 3, 2w plus 3, 5, sorry, and 2w minus 5. It's always good to check to make sure you actually are putting what you think you are. And I'll erase it so you can see it a little better. And there it is. Yeah, that's the one. Now, some people are going to say they can go directly from here to here, but why would you do that? It's so much easier to take it out first. And then you can see that it's a difference of squares, and it's a lot easier. Alrighty then, it's a perfect square and a perfect square, and maybe it's 10t plus 9 squared. And if we take 90t and double it, do we get our middle term? And we do. There it is. So that is a perfect square trinomial. And we've got 10t plus 9. Yep, and it's squared. Difference of squares, 8y plus 1, 8y minus 1. Notice I'm still putting the space. I'm not sure if it's absolutely necessary, but I'm putting the space in there for my subtraction just in case. Sometimes it likes it, sometimes it doesn't. All right, now there's no perfect square at the beginning. Now, one of the things you want to notice is that your first rule of factoring is to always look for a common factor. And we tend to forget that because a lot of times there isn't one, but there does happen to be a common factor here. And if you notice that 28 and 63, the only common factor is 7, then you can probably guess that 84 is divisible by 7, and it is. So we're going to take the 7 out. And again, I'm undistributing. I just want to know, what do I have to multiply by 7 to make this trinomial? I need a 4v squared. I need a minus 12v to get the minus 84, and I need the plus 9 to get the 63. Don't forget that the 7 is included, and this is a perfect square trinomial now. It's 2v and 2v and 3 and 3, and that negative tells us that they're both minus. And let's see, minus 6v and minus 6v, sure enough, is the minus 12v for our middle. So there it is. There's our factors. We say that that is completely factored. If they ever ask you to completely factor something, it looks like that. Now, again, we could write this as just 7 times 2v minus 3. And I will literally get students saying, oh, yes, I can do this in my head. I just did it in my head. Yeah, good luck with that. Anyway, it's going to be 7 times 2v. Don't forget to put the spaces. And we have a square. Make sure that that is exactly what I was looking for, and it sure is. Okay. Too easy. It's going to be a perfect square trinomial, and it's going to be k minus 4, isn't it? Now that one, I would say, yeah, you're supposed to do it in your head, not those other ones. Okay, a difference of squares, 6g and 11, huh? 6g plus 11, and come on, 6g minus 11. Looks good. Okay, this one went pretty quick. Looks like a difference of squares, except that that's not a perfect square, is it? Darn. So it looks like we have to take out the 2. Those are both even. That's going to give me 2 times 81r squared, and half of 128 is 64. Now I have a difference of squares, don't I? So let's do it. That's going to be 9r minus 8 and 9r plus 8. And that does give us our difference of squares, and our 2 still has to be there. Don't forget that the 2 needs to be included, okay? So we have the 2, and we have a 9r plus 8, and a 9r minus 8. And it looks good. There it is. Looks like a difference of squares. I mean, looks like a perfect square trinomial to me. And I am guessing 11q minus 10 squared. Well, notice that that negative gives us a big hint there. And if we take the product of our terms, it's negative 110q, and double does give us our middle term. So it's good to go. It's always good to check that, because sometimes they're going to trick you and they're going to say, you know, I mean, obviously it isn't all about the special cases. Q minus 10, and it's being squared. There we go. Okay, what do we have here? It could be a perfect square trinomial. 7j, and square root of 81 is 9. We have a minus. And is this the case? Well, let's multiply them. 9 times 7 is 63. And if we double it, we get negative 126. I'm going to double it without looking. Yep. It's always better to check your work without looking at it, because sometimes it'll kind of force your brain into thinking that it's something that it isn't. Anyway, 7j. I know we don't have a lot of things to worry about in this particular case. Raised to the second power, and it looks good. Could be a difference of squares. The only thing is 243 is not a perfect square. It is divisible by 3. Now that may not be obvious, but I notice that 2 plus 4 plus 3 is equal to 9. And 9 is divisible by 3. What that tells us is that 243, it divides 3 divides evenly into it 81 times. It also is true that 9 goes into 243 because 9 also goes into 9. Now for the 192, let's see if that's divisible by 3. Well, add those together, add the digits together. We call those digits, and you get 12. And that is divisible by 3, but not 9. So anyway, take the 3 out, and we do get 81c squared minus, and when we take out the 3, what do we get? 3 goes in there 64 times, doesn't it? Now we have a difference of squares, and we have 3 times 9c plus 8 and 9c minus 8. And there it is. There's our factorization. We say that it's completely factored. Don't forget the 3. That's a common mistake, especially when we're so close to getting done. I know you guys want to finish and be done with it, but I'm kind of enjoying this one actually. Looks good. 9s, yep, give me 81, and 8s give me 64. I have my 3 in front, and I spaced out my subtraction. Looks good. Okay. Oh, well, they're all even for sure. If I take out the 2, I'm going to get a 36 and a 49. So it looks good. Take out the 2, and I get 36d squared. Dividing by 2 gives me, what, 84? D. And dividing by 2 gives me 49. And now it looks like I have a perfect square trinomial, maybe. Don't forget the 2. I guarantee you're going to forget one of these times, so don't forget. We've got a 6d possibly plus 7. Oh, minus 7. Don't forget to check the middle term, huh? And a 6d minus 7 maybe. Well, let's see. That is negative 42d and a negative 42d. And sure enough, that's a negative 84d. So there they are. So 2 times 6d minus 7 quantity squared. And if you really want your teacher to be suspicious that you don't know what the hell you're doing, tell them that you factored this in your head. 2, 6d minus, oh, I want to get a space in there. And we want to square. And that is the one I'm looking for. Okay, what are we going to take out? And the reason I know I'm going to take something out is because that is not a perfect square. However, if I divide it by 2, it will be, because 2 goes into 98 49 times. 49 m squared minus 36. And now I have a difference of squares. Don't forget the 2. We've got 7m plus 6 and 7m minus 6. And sure enough, it works out really nice. 2, we've got a 7m plus 6. There we go. Minus 6 maybe. And I'm just going to erase that to make sure it's right. There we go. Double check it. It looks good. Looks like we got it. Looks like a couple more. Okay, we've got a perfect square in the first, and we got a perfect square at the end, don't we? 121 is 11 squared, and 6z squared. 6z squared plus 11, it looks like. And that would give me a 66z in the middle. If I double it, do I get my middle term? 132. Yes, I do. Okay. Get rid of this so it looks pretty. Parentheses, 6z plus 11. And we are squaring it, aren't we? Looks good. And looks like we have 2 more. Dang, they really want us to work. All right. That's a difference of squares. Don't even need to mess with it. 7h. Oh, be careful. 11h, how about? Minus 7. And how about an 11h plus 7? And that is a difference of squares with 121h squared and a minus 49. Yep. And we have one last one. Looks like a perfect square, maybe. But 128 isn't a perfect square, is it? 128 is double a perfect square, and 162 is double a perfect square. So take out the 2, and we get a 64s squared. We get a 144 in the middle, 144s. And our last is plus 81. And it's looking good. That looks like a perfect square trinomial. Don't forget the 2. Looks like we might have an 8s plus 9 and an 8s plus 9. Now it's a good idea to check. 72s plus 72s. Does that make 144? And it does. It sure does. Very nice. So we want 2 times 8s plus 9. Double check to make sure I have a positive there, and I do. Squared, and we're all done. I hope you'll do yours too, and do your special cases and enjoy your Christmas present. I'll see you back. Bye-bye.